Hello and welcome to the eTech podcast with me, your host, Ryan Morn. I have been involved in the development of electrified vehicles and machines since 2005 as an engineer and a business leader. This podcast is the product of my passion for electric and autonomous vehicle technology. I'm here to share knowledge from some of the world's leading experts as well as my own insights. Join me as we accelerate the transition to cleaner, safer and smarter vehicles and grow the industry around the world. This is our third podcast. Thanks very much for the feedback on the first two. Thank you very much for your time now listening to us, wherever you might be in the world and whatever you're doing. So today what we're going to talk about is Dieselgate. So this follows on from a white paper that we put out a few weeks ago, which can be found on our website. The link to that is below. Talking about the Dieselgate scandal, we put that white paper out in the aftermath of the arrest of the Audi CEO. So that was huge news in the industry. That's had quite a few knock-on effects. And so basically what we were saying was, look, it's 3 years after the Dieselgate scandal first erupted. We're still seeing the after effects of that shake the industry. And lots of people were still asking us, well, what does it really mean? Like, what are these defeat devices? How do they work? What impact will it have? If it was as easy as simply updating the software, why didn't the manufacturers do that in the first place? You know, what was going on there? So really, first of all, start by thinking about what is a defeat device. So basically, on a diesel engine, you've got engine ECU, which controls the engine, controls all of the engine functions, so the timing of the fuel injection into the engine and all of the other variables that are going on. And basically what the manufacturers were doing with the help of some of the tier 1 supply chain was putting software into the vehicle and engine ECU, which detected when the vehicle was driving on the emissions test. And you might think, well, how can it do that? Well, there's a few different ways. So the emissions testing was a very controlled driving profile. It was typically carried out on a chassis dynamometer indoors under certain conditions. So, for example, there were no steering inputs, but the vehicle would be driving from certain speeds. So basically the vehicle ECU said, oh, hang on, my steering wheel isn't moving, but I'm going through this very standard testing cycle that I recognize. I need to modify my behavior. So that really was a defeat device. It's not a piece of hardware, it was a piece of software that learned when it was on test and then modified the engine's behavior to change its performance. So that was a defeat device. It wasn't a piece of hardware, it was a piece of software which learned when the vehicle was on test and modified the engine's performance. So then what was the defeat device software actually doing? So on a diesel engine, basically diesel engines are very efficient, everyone knows that. And the reason for that is because combustion takes place at really high temperatures and pressures. So a diesel engine is what's called a compression ignition engine. So there's no spark plugs in it. And basically, literally the heat generated by compressing the charge air in the engine by the pistons as they go up is sufficient to ignite the fuel when it's injected under pressure as a fine mist. So that's great from an efficiency point of view. The fuel gets burned really well. So that means low CO2 emissions, good efficiency, good fuel consumption, lower operating costs. But that's bad for the formation of particulates and nitrous oxides in the exhaust gases, because at those very high temperatures and pressures, high temperature pressure combustion, that's where you get those NOx and particulates forming. So in order to control the production of NOx and PMs inside the engine, you can have variable injection timing. So you play around with the injection timing to basically make injection happen at a suboptimal point. So you reduce the combustion pressure and temperature, and that helps. You also recirculate exhaust gas. So a lot of people, I think that exhaust gas recirculation is all about burning off unburnt fuel in the exhaust. That's not what it's about, actually. Why you recirculate exhaust gas is to lean out the inlet charge. So you basically reduce the temperature and reduce the oxygen content in the inlet air. So that makes it basically harder for combustion to happen, which also reduces the formation of NOx and particulates. But both of those things have a negative impact on fuel consumption. Okay, so then And then outside of the engine, there's two primary exhaust after-treatment technologies. So there's diesel particulate filters are used across the board, but then we have LNT, which is lean NOx traps, and SCR, which is selective catalytic reduction. So an LNT is quite a clever device, but basically these are the devices where there was all the problems. So LNT doesn't work very well, basically, and the manufacturers that were using LNT were having then to come up with clever strategies for how they might make it perform so it passed the tests. SCR is really expensive. It requires an extra fluid in the vehicle. It works really well under most conditions. The hardware is quite expensive that you need to do it. So some manufacturers preferred LNT over SCR because LNT appeared to be cheaper, but it didn't deliver the performance. So basically that's where these defeat devices came in. So if we have an LNT equipped vehicle, we're trying to make it pass the tests, but there's two things that a vehicle's being tested for, not at the same time actually. So one is for the exhaust emissions, so we're looking for what's happening with NOx and particulates in the exhaust. And in that situation, the defeat device was turning on and making the engine perform in one particular way. And then the other tests are being carried out are for fuel consumption. So that's your miles per gallon, that's your CO2 emissions. Really, that's a selling feature of the vehicle because it should just achieve emissions compliance anyway. But then how well it does on miles per gallon or litres per 100 kilometre and those running costs of the vehicle, that's what sells the vehicle. The other big driver for CO2 targets is that all the manufacturers have got targets to hit in terms of CO2 reduction targets. So they've got an incentive to reduce CO2, otherwise there's big fines for them. So the defeat devices came in there. So then what's happening when we remove the defeat devices is basically the engine ECU is being reprogrammed so that under normal driving, it's doing all the things it should have been doing to achieve full emissions compliance. So that sounds really good, except the problem with that really is that the old testing regimes were so narrow, the test profile was so lightly loaded, that actually even if you are achieving the emissions compliance on the NEDC cycle, it's such a lightly loaded driving cycle that there's still loads and loads of the cycle where you're not compliant and in kind of real world driving. So when the engine's heavily loaded, etc. And that's why you've got a situation where some manufacturers were definitely cheating and they were caught, and quite a lot of manufacturers were not cheating, but it was being found that their vehicles in the real world were a long, long way from the emissions test results, and that was just simply because they were very, very optimized to pass the emissions test, but then in real world driving, basically they didn't manage to achieve anywhere near the same level of performance. So this has led to really the biggest change in the industry, which is the introduction of these really demanding new testing profiles. So there's two new tests that have come out. One is the RDE test and one is the WLTP test. So the RDE test is literally real driving environment, and the purpose of that is that the vehicle is driven on the real roads in kind of conditions that represent how a vehicle would normally be driven. So that's really interesting, really valuable, but it's really difficult to reproduce. So you can send 10 cars out on 10 different days with 10 different drivers, and the results are going to be different every single time. So in one way, that's really good, in that it means there's nowhere to hide. In another way, though, it makes it very difficult for the manufacturers to do their engineering and development work. So that's why we've got this other laboratory test profile, the WLTP, which is being carried out. That happens on a dyno against a standardized cycle. But this time the standardized cycle is much, much more demanding than the old NEDC cycle. So there's less scope to optimize for the very lightly loaded portion of driving and basically have a highly optimized test result that then isn't replicated in the real world. So we've got real world driving tests, and we've got the WLTP laboratory tests. So that's a massive change. And then the other thing that's happening is it's leading to the implementation of new technologies. So some of the things that Avid's worked on for a long time, such as electrified engine cooling pumps, electronically controlled thermostat valves, they weren't very popular because basically the OEMs tested them, and whilst they had benefit in the real world, they didn't show a benefit on these very, very lightly loaded driving cycle tests that happened in laboratory conditions. But what now it means is, because we've moved away from those lightly loaded tests to more representative real world tests, that these electrification technologies actually do work, and they do help to deliver more efficient engine, and they also help significantly with emissions compliance. So just for example, something like electrifying the engine thermal management system or cooling system. So basically you go from a belt-driven engine cooling pump to an electrically driven pump, an electronically controlled thermostat valve, and electrically driven fan. And what that means is you can very carefully control the cooling or thermal management of the engine, so you can make sure it warms up very quickly, it stays at its operating temperature, doesn't bounce around the thermostat opening point. So you've got more consistent engine temperatures, which means you have better operation of the exhaust after treatment system, and you've got an easier to control combustion environment in the engine. You also take off some quite significant parasitic loads from the engine. So all in all, just it makes it a much easier, much better package. Obviously these things add some cost and complexity into the system, but on balance it's worth doing that for the benefit that you see in the real world driving performance of the vehicle. So as well as electrified systems on conventional engines, the other thing that's happening as well is that really some manufacturers are saying, look, it's just not simply not worth the investment. The extra costs it's going to add to our vehicles to have a true real world compliant diesel, we don't think we're going to sell any. We don't think the consumers will pay that for that product. So we're going to stop making diesels altogether, and what we're going to sell instead are hybrid petrol or gasoline, depending on which country you're in, products. So that's also great. So electrified gasoline engine. So basically you've still got an engine, but you've got a hybrid system alongside it. Also typically electrified ancillaries in the same sort of way. So these new tests are leading to the development of an awful lot more electrified powertrain in vehicles, which is really coming into the market in full force. So then just in summary, Dieselgate, huge impact on the industry, probably the single biggest thing to happen to the industry since Henry Ford invented the production line methodology. It's had a lot of negative consequences, but also positive consequences coming out of it as well. It really has highlighted the air quality issue, which is a massive issue that we've been talking about for years now, but people have been failing to get to grips with. It's led to the development of new, more demanding test profiles that give us more representative results from the vehicles when they're being tested to when they're being used in the real world by us, the consumers, which in turn is leading to more electrification in the vehicle powertrain. So more electrified components alongside the engine, and more hybrid systems, but also ultimately it helps tip the balance in favour of fully electrified vehicle powertrain, because essentially the baseline cost of your real-world compliant diesel is now that bit extra higher. So as battery costs continue to fall, full EVs continue to get cheaper and cheaper, actually conventional engine vehicles are getting more and more expensive. So it's really been a massive thing for the industry, and it'll continue to have impacts for many years to come. Okay, so that's all for today. If you've got any comments or questions, I'd love to hear them. We've had loads of feedback on the first two podcasts. Either leave it below or get in touch with us and we'll get back to you. Or if you've got an idea of something you'd like to talk about, get in touch for a future podcast. Make sure you subscribe so you get updates from us. We're doing podcasts, 1 or 2 a week. So not every day like some people, but a couple a week, talking about topics relative to the automotive industry, but also technology, robotics, and more things coming down the line. Some really interesting podcasts coming. So subscribe, like, leave us a rating, and I look forward to speaking to you again soon.